Welcome back. We're going to continue chapter 2. We're still at research methods. We're going to talk about reliability and validity, which, again, those of you who have taken research methods know about this very well. This is a very simplified version of it, reliability. We usually look at inter-rater and test-retest reliability. Reliability is the consistency and repeatability of a measure, right? So if I were to give the same measure again, will I get similar results? Will it test the same thing again, is what you are basically trying to figure out. If you have coders, it is very important to do inter-rater reliability. So if, for example, one of your peers, actually friends, came over and said, I would like to join an ongoing study. I said, would you like to code? Why? I need coders. Why? I have video data, correct? And I can never rely on one rater's rating. I need to establish high reliability between two raters at least if I'm going to use the codes that they produce. And so that is inter-rater reliability. Test-retest is, again, giving the same test and expecting to see similar results. Validity is how accurately the measure captures the characteristics the researcher is trying to study. Are you really, really measuring what you are out to measure, or are you measuring something else? Internal validity is usually about study conditions, and external validity is about generalizability. Again, very simplified as compared to last semester, but this will be enough for the semester. I will not grade Psych 204 students' papers differently if I ask a question from 204, obviously. General research designs. How do we construct a framework to test what we are out to test in developmental psychology? As you know, experimental designs require that what? Banu? We have to temporal precedence, yes. What were the other two? Covariance and? Yes. And we, in an experiment, a defining feature of an experiment is that what do we do with the independent variable? Yes, we manipulate it. If we can't manipulate it, then it is not an experiment. That doesn't mean it's not a study. It's not research. It is research. It is just not called an experiment. In order for something to be an experiment, you need to manipulate the independent variable. Okay. So, for example, if we were to what? I'm sorry for the very lame example, but I'm trying to give an example as fast as possible. If I were going to try to see whether giving you study slides actually helps your performance or not, one group would receive study slides, one group would not receive study slides, meaning I would be manipulating the independent variable, the presence or the absence of study slides, to see your performance. Now, in developmental psychology, we, unfortunately, maybe fortunately because of ethical reasons, cannot actually manipulate many of the variables that we are really, really interested in. And so we end up doing a lot of correlational work too. For one thing, as you know, we cannot manipulate children's age. They come already made, God-given. We can't pretend a 3-year-old is a 5-year-old just because we want to. We can't do the same thing with gender. We can't really do the same thing with vocabulary, for example. How much vocabulary competence a child has. SES. SES, yes. These are things that I wish SES we could have control over it so everybody could be rich, but unfortunately we are bound by reality. And what do we do when we do correlational design? We have two variables and we want to see whether they are related. If they are related, how are they related? And whether they are related strongly, moderately, or weakly. The strength of that relation, that we are interested in. Okay. And so if we're looking at whether children who watch more TV are also more aggressive, we don't select children and expose them to violent TV. Instead, we basically measure children's viewing and then see if it relates to the amount of aggression they display. And it's measured by correlation coefficients. You know all of this. I am not going to spend time on this, but it's there for you. There's positive correlation and a negative correlation, as you can see. Here's the positive correlation, which means what? As one variable, as the value of one variable increases, so does the other, correct? The scores that participants get. These dots are participants, you remember, and the negative correlation is the reverse. So when one participant is scoring higher on one variable, they're actually scoring lower systematically on the other one. That's a negative correlation. Now, the problem is interpreting correlations. It is very easy to display, but we all sometimes make an error when thinking about correlations, and nobody's immune. I'm not immune. You're not immune. When we find a significant correlation, sometimes we want to believe that it's causal, but it isn't. Correlation is not causation. For the very simple reason that we have no idea of temporal precedence, meaning we don't know which one comes first. So this is a very illustrative example, I think, from your book. So is it that the first variable causes the second variable? For example, our children who are more intelligent also have more friends. It's because of their intelligence that they have more friends. Is it? Or could it be the other way around? Those children who have more friends are exposed to more language input, more social input, more emotional input. Hence, they end up being smarter. Or maybe neither variable is caused by the other. Both are caused by a third variable. Say, parents who are warm and supportive have children who are both more intelligent and also have more friends. So we have to be very careful when we think about correlation. And we should refrain from thinking about correlations as if they were causational relationships. Sorry. I said all of this. Okay. Independent variable, dependent variable. We again know what these are. Independent variable is the manipulated variable, the variable that we're interested in to see its effect on the other variable. The dependent variable, experimenter measures it but does not manipulate. It's expected to be influenced by the independent variable, but sometimes we can't, as you know, manipulate it, so then we rely on these distinctions. Yes. Third variables. A third variable is a variable that correlates with the dependent and the independent variable and may partially explain the relation between the dependent and the independent variable. Let's go back and look here. Here is the third variable, correct? Yes, so this is a third variable in this relationship. It affects both variables and it actually explains the relation between those two variables partially. Maybe not fully, but partially. Okay. Confounding variable. Very important. What is a confound? Huh? Who's talking? Huh, Merve? Yes. Which one? The levels of the IV, I think. Huh. Very nice. Use the keyword systematically, ISO. It is usually researcher created. It is usually an oversight, correct? And it systematically varies between the levels of the independent variable and biases the results as a result. Now, for those of you who weren't with me last semester, can we give an example that makes it so much more clear for those who didn't take 204? What about SES? Being smarter. Let's go for a simple, yes.
You want to do research about children who are inclined to do arts, and you go to different schools and you do research. A compound would be if you go to a specific neighborhood and pick children who study there, like go to schools that are there. So you basically are making and creating a compound in terms of ACS, because if you go to Bilkent, for example, or just Chayogo, there's a certain group of people who live there. They have certain status, economic status, so you're basically, they are maybe probably more likely to be inclined to art because of their economic status.
Yes.
So basically creating a compound.
Economic status or other special circumstances such that, for example, if you are doing a study on Bilkent grounds and you're interested in musical ability in children, you actually have here a neighborhood that has a symphony orchestra play every other week, right? There are a lot of neighbors, friends who actually are in the orchestra. There are a lot of students who study music at Bilkent who give lessons for very affordable prices. And so you have this neighborhood where, you know, musical ability is fostered more so than if you would actually just go over to the next neighborhood, even if the SCS were the same. And so if you were to put these people in different groups, that's the level, systematic difference between the levels, then you are probably biasing your results because the groups are going to give you very different results based on the conditions that they're living in, which as a researcher you didn't take into account. That makes it a confound, yes. You should carefully design your study, and you should also use random assignment to levels or to groups so to avoid these problems. Modified experimental designs. Field experiments is capitalizing on rare opportunities to random assignment in natural settings. This is what I'm doing at this moment. I am very, very excited. So apparently, the Bliss School on campus decided to buy tablets for their preschool kindergarten classrooms. And they want to understand the changes in teachers' perceptions before the tablets are given to them, and then after. Then they came and asked whether I would be willing to take part in a workshop for these teachers in April. So we quickly designed a study in the past week. I'm not going to let that pass. And so what are we going to do? We're going to basically, we already designed the questionnaire. We're about to distribute it to teachers about their perception of tablet use in preschool classrooms, whether they think it's going to be effective. There are a lot of questions. It looks at their perception of efficiency, usability, their own mastery of digital content. And then we're going to, before the workshop, we're going to give it again. The teachers will have had about 2 months of constant exposure to these tablets in their classrooms. At the workshops with them, we're going to produce projects that they can use in their own classrooms. Then we're going to go back and test them again in June, after they have used the projects they created with tablets themselves, to see how their perception and attitude changes. Now, did I design this study? I mean, I did, but it's basically a natural field experiment in a way, because it was already unfolding. They were going to give these tablets and give a workshop whether I wanted to or not. What I did do as a researcher is taking advantage of it, but I provide my services also by putting together the questionnaire because they did want to learn about teachers' perceptions. That's why they came to me. And also, they did want a workshop. So I'm going to take part in that. So it's going to benefit the school. The school is interested in what I want to find out too. So this is a very nice, you know, hitting 2 birds with 1 stone kind of research. That happens rarely, but I very much enjoy it when it does happen. What's a quasi-experiment? Quasi-experiment is what we end up doing most of the time. It compares differences in treatments that already exist. So you can't manipulate a variable. It is there by nature. And groups are already formed. You didn't assign people. There are boys and girls, 3-year-olds and 5-year-olds. You basically compare them. And that is quasi-experimental research. You're not looking at the correlation. You're still looking at difference in groups. And that makes it a quasi-experimental design. There are other designs. There's longitudinal, cross-sectional, sequential, and microgenetic. And some of this, the 204 students don't know either. So everybody's on equal footing. Longitudinal designs. Longitudinal designs track participants over several time periods. It could be years, it could be months, it could be semesters, you know. But basically, you take the same kid, and test them again at time 2, test them again at time 3. When the kid is 6, in this case, when the kid is 6, 9, and 12 years old, it's the same kid. What are the advantages of longitudinal designs? It permits studying common patterns and individual differences in development, and it permits studying of relationships between early and later events and behaviors. This is especially important because we can't manipulate some of the variables that we're interested in. So seeing how it longitudinally unfolds actually gives us better grounds to start thinking about causality. We still can't conclude that A causes B, but we have better footing in terms of whether A could cause B. Right. The problems, well, usually it could end up, we could end up with a biased sample, usually because of selective attrition. Selective attrition is, so this is what happens. You start with 150 children, let's say, and you talk to the parents, everybody knows, 1 year later you're going to go back and test the same 150 children. Next time you go, some parents don't want to sign the new consent form. They say, we're done with this study, we've had enough. Others have moved. You can no longer find the parent or the child, right? The child may not consent. Oh, I remember this, I remember you, it wasn't fun. I don't want to do it again. And so you end up with, say, 120 kids. Who are these 120 that remains with you? And are they different than the 30 who left the study? That's attrition. Okay? And it could be that you end up with a more biased sample. Practice effects, cohort effects, giving the same test twice leads to practice effects. The child may remember either the test or their answers to the test. There could also be cohort effects. Cohort effects, think of cohort as, it's not exactly a generation, but think about it in loose terms like a generation. So I wanted to do a study, let's say, and I did this 10-year study with children that were born in I can't because I'm not that old, but let's think about it that way, 1970. And then, well, the kids born in 1970 may not actually be representative of the kids that are born in 1990 because of the differences in the environment, especially technological media. The kids who are born in 1990s might have been exposed to computers and other digital media earlier in life. What was it, this class? People are born 1997. 97, okay, I will never forget that. And so the world that you are born into had cell phones already in place. Most likely when you were born, your parents called their parents on their cell phone. In 1997, I can tell you that much. In 1997, phones were very, very expensive to buy. I myself had to work for one because otherwise my mom wouldn't let me drive at that point in time. She said, there's a car, but you can only drive it if you have a cell phone. I had to work for months to get the money together to get the cell phone. She on purpose didn't give the money so that I would not drive. Yes, they were that expensive, the Ericssons, the Nokias. And so, yes, but for you, it's not a huge difference that you have access to it. The smartphones came pretty early, too. Probably your first phone was kind of smarter than the very first phone that I ever had. Mine could dial. And text messaging was uber technological at one point in time. People wanted to be messaged. Now it's banks who are messaging you, and you don't want any more messaging from them. Yes? And so cohort is basically a generation, but generation is something, a generation in sociological terms usually is every 20 years, but think of it as born at a time or a certain age at a time. These children are different than others. It could be because of a political situation in a country that children born 5 years before or after a certain date could have experienced very different environments. And in longitudinal design, some things may become outdated due to changes in theories and methods. Oh my God. It happens most often with technological research. For example, now once meaning 5 years ago, companies were selling preschools these CDs that had stories in them. So the children could go sit at the computer, put the headphones on and listen to them. Now they're on iPads, right? And so it had a very short lifespan. I mean, I'm sure it's still being sold and the preschools that bought them are still using it. But I assure you 10 years from now, it won't be a major retail category for preschools. And so what it is there was research done on them too. Children's listening to stories from computers. That research is already outdated. Why? Because nobody listens to stories from computers anymore. Everybody listens to them either on a phone or on a tablet. You might say, well, who cares if it's on a computer or a tablet? Why should we care? Well, with a tablet or a phone, you can interact with it more. So it comes with more features, right? So on the computer, you click the mouse, things. But now that the kid can actually just swipe or just tap with their own finger, even younger children, because 2-year-olds, 1.5-year-olds, 2-year-olds, 2.5-year-olds weren't very apt mouse users, but they are very apt at finger using. So these apps that are developed nowadays have more affordances to interact with the kid. And so the research has already become a little bit dated. What if you were doing a longitudinal research? You're going to track these kids in 5 years. Well, by the time they hit the second time of testing, the technology you're basing your whole research on is already a little bit outdated, right? And so it can also happen. But longitudinal designs have a lot to offer. That's why people try to do them. Cross-sectional design. What is a cross-sectional design? It is what we have been doing in our lab. We basically take kids from different age groups, for example, test them and compare them. So we compare 3-year-olds with 5-year-olds. Are they the same kids when they were 3 and then when they were 5? No, that would have been longitudinal. These are different kids, right? And so that's basically what a cross-sectional study is. It is efficient, and it's not plagued by selective attrition, practice effect, or theoretical and methodological changes in the field. But the problems are it does not permit studying of individual developmental trends. So how does one change through time? It gives less information. Age differences may be distorted because of cohort effects, because these kids might belong to different cohorts. We talked about what a cohort is just a moment ago. We also didn't say it in the longitudinal research, but in longitudinal research, the error that is due to individual variance is minimized, correct? Do you remember? Because each person acts as their own control, if you remember. But in cross-sectional design, that error is larger. Yes. But the thing is, at 2002, you have 9-year-olds and 6-year-olds. You tested 2 different age groups. 3 years later, you're testing the same group of kids. So what is happening is that you're basically doing a longitudinal design, but you have 2 different age groups that you are following through time longitudinally. Does that make sense now? Thank you very much. And thanks for pointing that out too, because it was basically making my explanation of it very confusing. Yes. Okay. So in a manner, it's because at one time point you have tested both children at different ages or stages in development, you can do cross-sectional comparisons and look at short-term effects. But also, since you are following these kids through time, you can do longitudinal effects as well. You can test for cohort effects because you're going to now have cohorts at different points in time. So you're going to have people who were, say, 7th graders in 1985. No, you have 7th graders in 1986, and then you have 7th graders in 1987. You are testing both. And comparing these two and seeing if there is no difference will tell you that cohort effects are not being a problem. The same thing, you can see you have 3 groups of 8th graders to compare with one another. Meaning you can see if your cohorts are different than one another, because you don't want cohort effects that you are trying to eliminate. Having different cohorts at different time points allows you to do that, basically, because these are not going to be the same children. Okay. We talked about cohorts. And lastly, we're going to talk about microgenetic studies. You know, in longitudinal designs, there are long time gaps between 2 testing times. You are trying to see development. In microgenetic designs, you usually are trying to see development in slow motion. You know how you take a video of something and you can do a slow-mo version of it? That's what a microgenetic study is. You test the same child again and again and again over a short period of time. You are not really interested in performance per se, but how that performance changes from one testing to the next. Who does this more often? More people who are more interested in learning, for example. How does a child learn to do a specific task? What are the steps that they go through? It could be problem solving, yes.
Doesn't this cause learning effects? Doesn't this cause learning effects?
Yes, it can cause learning effects. Usually what they do say, I am trying to see how a child uses strategies in adding. Okay, the child is learning to add 2-digit numbers. I am very interested in seeing the strategies that the child uses. And so what I may do is I may give 10 problems one day, 10 problems the next day. So you're not giving the same 10 problems. Since you're looking at learning, you can keep varying the stimuli that you give as long as the ability required to solve that problem remains constant. Okay? And so what you're doing is tracking that child's learning curve. These gives you curves. And understand how in micro time change happens in learning. So here is anybody named Ali? With guys' names, I'm much more fortunate because there are fewer of them. So Ali on Monday, Ali on Tuesday, Ali on Wednesday. So what you are basically looking at are those little changes. Yes.
What if it is shorter than a day?
It
Like
can.
I remember from the cognitive class
Mhm.
that some researcher were testing himself over 15 minutes and after 20 minutes, and he was trying to learn unmeaningful verbs. The Ebbinghaus. Is it also microgenetic?
Ebbinghaus was less interested in the process and more interested in the outcome. But yes, you can test. I mean, it doesn't have to be. There is nothing that says it's a day. Okay? It could be 3 times a week too. It doesn't have to be every day. Day here is just to give you a sense that it is more frequent testing. Yes. Yes. It can be time consuming. It can be difficult. There could be practice effects. Elif, you said practice effects, correct? Yes. But usually people try to get over that by giving new stimuli. And as we said, it offers insight. So in developmental psychology, we are very interested to know or describe change. What does a typical 3-year-old do? What does a typical 5-year-old do? What does a typical 7-year-old do? But we're also very interested in telling others why change happens and how it happens. In order to answer those questions, we need to have insights into the process of change. The process of change comes with these kinds of designs, which look at why and how change is happening. Okay? And that's why people use microgenetic designs. Ethical standards. So, as you know, American Psychological Association has come up with certain ethics codes for studying both human participants, but there's also ethic code for studying animal participants as well. In human participants, children are a special population. They're a vulnerable population. Their consent is usually given by their guardians, their parents. And so it is very important for us to treat them with being extra careful, with being super careful. And for that reason, there are certain standards that we have to uphold. We need to protect children from harm, even when they consent because they don't know better. We have to think for them and we need to protect them. We should not be asking them to do fun activities that might harm them, for example, right?
Bungee jump. Bungee jump.
On the
Bungee jumping.
bungee jumping, okay? Well, we don't, there is no study that actually hurls little children over cliffs tied to a rope that I know of. I think, have you done bungee jumping yourself? No. You actually sign a consent form, if I'm not. Has anybody done a bungee jumping, done bungee jumping here? No one. Is it no one or nobody wants to admit it? Because Emre Bey is here, no? Okay. Well, it's the best of my knowledge. I haven't done it either. But you actually sign some kind of consent, some kind of release before you hurl yourself over that.
I didn't know it.
Yes, so if anything happens, you can't sue them. Bunu düşünerek hareket etmekte fayda var. Yes. Informed consent. Informed consent is you write a consent form. That consent form basically tells what is going to happen in the study. But who are you writing this consent form? These are children. You are writing them for the parents. And the parents have to consent according to Bilkent University's rules and regulations. If a child is going to participate in one of our studies, both the mother and the father has to consent. If one says okay and the other says no, we say okay, kısmetliymiş. Yes? And do we get that? Sometimes we do. I don't know what it is with fathers, but mothers are ready to sign. Fathers say, I want no videotaping. And so, but also this is very important. Why don't people want videotaping? Because in this day and age, they are very scared. What if you put the video of my child on the internet? Somebody once asked me, are you going to put it on YouTube? No. Why would I? But it's important. I mean, you know, there's a lot of video information that people post willingly, and now posting videos on YouTube or other types of sharing platforms is not difficult for any of us to do. And nobody wants their child, for example, consistently failing at a task being on a video. So if we were to share their videos, we would need to get that consent. It has to be in the consent form. They need to be informed about the results. When we do our studies and get our results, we make sure that we write summaries in ways, they're in Turkish, and they're in ways that parents can understand. They don't have to be psychology majors to understand. And then we email them, send hard copies, and also do a morning, we did it this November 5th, I think, Saturday morning, where we invited parents and we basically presented the results of all the studies that we did last year. How many parents came? 20. Out of how many? 250. It's okay. What we need to do, and also the parents who came, I mean, almost all of them had not participated in a study. So they learned from the parents we sent the information to. So somebody said, hey, my child participated in a study, it was fun, they're giving a talk, I can't go, would you like to? And so they came. So we had 20 people who had never been in a study. It's okay. Our job is to do it though, and we're going to do it again next semester. So we were left with a lot of kuru pasta, as you can imagine.
We ate them all together. You gave them to us. Do you remember?
Yeah, when you say we ate them all, it feels like Sevgi and you ate like 3 kilos of kuru pasta.
We did.
seems impossible to me. It was a small mountain. I see. Okay, next year I know who to give the crew pasta to. Okay. Beneficial treatments. We talked a little bit about this in research methods. We can't waste children's time if we know that the treatment they're in is going to give no benefits to them and the other group is going to get some benefits. We need to make sure that their time is not wasted. So comparison groups, people. So we have to do treatment that will benefit them too, is theoretically meaningful, is also meaningful in terms of our hypotheses, right? You can see this, there's a table, 2.5 in your book. Look at that table. It actually very nicely explains all of these. Again, children's research risks. Risks are mostly psychological. Some increase with age, others decrease. Younger children are unable to make reasoned decisions, and older children are susceptible to self-image issues. So they want to present themselves cool, or they want to present themselves intelligent. And children's unique characteristics, their family backgrounds, their experiences may provide unique vulnerabilities, individual vulnerabilities. And researchers must reconcile the risks versus. What does that mean? It means that you basically put it on a scale. The benefits always have to weigh more than the risks, right? For us to justify to ourselves that we are taking that child's, that parent's time. Usually we have minimal risks. That's what we try to do. I mean, at least in my kind of research, there's almost, I mean, the most that can happen is boredom maybe. But it's not as great as some of the cognitive research you guys are, no way. Because what makes it very challenging with children, research with children, is that children will not answer questions if they are not having fun. Thank God you're not children. Imagine I'm giving you a midterm and I have to entertain you the whole time for you to answer the questions. That's what it is. What is your name? Yes, you. Mohammed. I'm like, Mohammed, please answer this question. Look, there's a bunny. What are the different research methods that we use? No, with children, it has to be meaningful for them. And meaningful for them is usually a fun, comfortable context, especially with the preschoolers that I'm working with. The moment they stop having fun, the moment the answers stop. So my job is double difficult because, as I said, I can't give them GE credits. They won't understand that. And the tester's job is difficult. Why? Their energy has to be upbeat and very consistent. If they're themselves tired and yawning, I see some of you guys testing for social, like, so you're very upbeat, you like take the participant in, the participant goes in, you close the door and you're like, ah. For us, it's a show, it's a performance. If you're testing a child for 50 minutes, for 50 minutes, you are there performing. That is why you may think twice before you go into, I'm looking some of your faces and you guys are already in the lab. This is not to scare you. This is just to let you know of what might be difficult. I have 5 minutes for discussion. We've already watched Jeannie's video. We've already talked about ethics. We talked about research design as well. What are some of the ethical violations in the handling of Jeannie's case, do you think?